For today's lesson, we will be discussing about situational problems involving conic sections. So this time, what we will do is we will try to solve problems involving conic sections. So before we proceed with the discussion, let's recall first what are the four conic sections. So we have circle, we have parabola, we have ellipse, and then we have hyperbola. So please take note of the properties as well as the equations that is used for each conic sections, because we will be using it later on when we are already answering the word problems. So for our first example, let's have this word problem. A street with two lanes, each 10 feet wide, goes through a semicircular tunnel with radius 12 feet. How high is the tunnel at the edge of each lane? Round off to 2 decimal places. So whenever you're given word problems like this, you have to identify what kind of conic sections is involved. So is it circle, parabola, ellipse, or hyperbola? Sometimes it is explicitly mentioned, but there are times that you just have to find keywords for you to determine the type of conic section involved. So by looking at this word problem, so we can take this word semicircular tunnel. Okay, so that means we're dealing with half of a circle, or we're dealing with circles. So that means we will be using the concept of circle in answering this particular word problem. So after you identify the type of conic section, you have to illustrate. Okay, so when you are illustrating, it's helpful if you will put it in a Cartesian plane or coordinate plane, so that we can identify some things that we can use in order to solve. Okay, so again, we have a semicircular tunnel, and let's say we will put it in a Cartesian plane. So like this one. So this red curve here, this is our tunnel. So as you can see, it's semicircular. You can place it wherever you want, but it's easier if we will use the origin as the center. Okay, so this point right here. Again, you can place the figure anywhere you want, but again, it's better or it's advisable if we will maximize the use of the origin. And so in this example, we use the origin as the center of our semicircle, and then again, this curve right here is the tunnel, the semicircular tunnel. Okay, another thing is we have here the radius is 12 feet. So as you can see here, so there we have here, this one is 12 feet. So this one represents the radius, this segment here, and as you can see, it's 12 feet. Next is we know that there are two lanes, and each lane is 10 feet wide. So as you can see here at the bottom, we have here this line segment here. So this two line segment on the different sides of our plane, this displays the streets or the lanes that we have. Okay, and each of them is 10 feet wide. So as you can see, it's up to 10 only, 10. Now the question is, how high is the tunnel at the edge of each lane? So again, this is our lane, this is the edge. How high is the tunnel? So we're referring to the height. So if we will put a line here, again, we're referring how high is this. So this is the question. How high is the tunnel at this particular point? Okay, now let's say we have here this point P, which represents now the edge of our tunnel. Now you can get a point from our tunnel or from our semicircle that will help us to solve this problem. So in this case, we have here this point P. So this point P right here represents now the height of the tunnel at the edge. Okay, so we know this one is 10. If we will get the coordinates of this point, we know that the x is 10 because that is the width of our lane, and then we don't know the height, so that is y. So y now is missing. In short, what we need to identify is that given our semicircular tunnel with radius of 12 feet, what is the value of y given that the x is equal to 10? So that is what we need to solve now. So to solve that, we have to be reminded of the equation of circles. So we know that the standard form for the equation of circles is we have x minus h squared plus y minus k squared equals r squared. From the problem, we know that hk, or our center, is 0, 0. So again, this one is our center. It's 0, 0. We also know that the radius is equal to 12. So let's use this information and substitute it to the standard form for us to get the equation that represents the tunnel itself. So we have x minus 0 squared plus y minus 0 squared equals 12 squared. Simplify this, we have x squared plus y squared equals 144. This now is the equation that represents the semicircular tunnel, or the whole circle, okay, that includes the semicircular tunnel. Now that you already have the equation, we can now identify the corresponding value of y given that x is 10. Okay, so remember this point right here, we know that the x-coordinate of that is 10, and then we need to solve for y. So that is what we will do now. So given that x is 10, what will be the corresponding value of y? So we will now use this equation and substitute the value of x, and then solve for the value of y. So we have, again, it's x squared plus y squared equals 144. Then we have 10 squared plus y squared equals 144. This is 100 plus y squared equals 144. You move 100 on the other side. 144 minus 100. Then let's just continue here. So we have y squared equals 44. Then you get the square root of both sides, since what we need is just a y. So y is equal to square root of 44, or if we will get the approximated value of that, we will get 6.63. Okay? Therefore, we can say that the tunnel is 6.63 feet high at the edge of the lanes. Okay, so therefore this y coordinate of this point is 6.63. okay, so that is now our final answer, 6.63 feet. Next problem. A satellite dish has a shape called a paraboloid, where each cross-section is a parabola. Since radio signals parallel to the axis will bounce off to the surface of the dish to the focus, the receiver should be placed at the focus. How far should the receiver be from the vertex if the dish is 12 feet across and 4.5 feet deep at the vertex? So obviously, in this word problem, we are referring to parabolas. So again, we will be using the concepts that is involved with parabola in order to solve this word problem. We have here a satellite dish. This is a real-life example of a parabola. So this is how it looks like. Okay? In our problem, it was mentioned that the radio signals will bounce off to the surface of the dish to the focus. Since that happens, so the receiver should be placed at the focus. Okay? Remember, in our discussion with parabola, focus is the fixed point. So looking at this illustration, let's say the signals are these lines. So it will hit the dish and it will bounce to the focus. Okay? Since that is the case, so the receiver should be placed at the focus. Now the question is, how far should the receiver be from the vertex if the dish is 12 feet across and 4.5 feet deep at the vertex? So again, we can illustrate using Cartesian plane. Okay? So let's say this one is the dish. So it's parabola. Okay? And then we have here the focus, or this is where the receiver is placed. And we know that the dish is 12 feet across, so this one. So therefore, if the whole dish is 12 feet across, therefore this is 6 feet, and then the other one is 6 feet as well. And it is 4 feet deep at the vertex. So this one is 4.5. Now, the question is, how far should the receiver be from the vertex? So this is our vertex, this one. So again, as you notice, we use again the center, or we use again the origin as the vertex this time. Okay, how far? So this one, this is the one that we're solving. Since we know that this is the focus and this is the vertex, that means we are solving for the variable c. We have to identify now what is the value of c, because recalling the concepts of parabola, we know that c represents the distance of the focus to the vertex. So that is the one that we have to look for. Now let's solve. Again, our goal is to solve for c. Okay, because that represents the distance of the focus which the receiver is placed, okay, from the vertex. So with that, we have to use the formula or the equation for parabola. Now since this parabola opens upward, that means we will be using x minus h squared equals 4c times y minus k. Again, we use this formula because the parabola opens upward. From the figure, from the word problem, we know that the vertex is at 0, 0, because that's how we illustrate it. So let's use these values to substitute to our equation to identify now the standard form of the equation that represents the parabola. So we have x minus 0 squared, then y minus 0, or we have x squared equals 4c y. So this is now the standard form. Next thing that we have to know is what will be the value of c. So we can only identify the value of c if we have x and y. So looking at our word problem, looking at the figure, we know that this is 12 feet across. So that means each side is 6 feet, and it is 4.5 feet deep at the vertex. So if we will get a point, we will get a point here, which is part of our parabola, then we can have here 6 and 4.5 as the values of x and y. So x is 6 and then y is 4.5. Now let's use those values and substitute it to our standard form in order for us to identify c. So we have here 6 squared equals 4c times 4.5. So this is 36 equals, then 4.5 times 4 is, we have 18c. Then divide both sides by 18. So we have c equals 2. So therefore, the distance between the vertex and our focus is 2 feet. So we can say that the receiver should be 2 feet away from the vertex. So this is now our final answer. For our next problem, so the cable of a suspension bridge hangs in the shape of a parabola. The towers supporting the cable are 400 feet apart and 150 feet high. If the cable at its lowest is 30 feet above the bridge at its midpoint, how high is the cable 50 feet away, which is horizontally, from either tower? So as you can see, the problem, it involves parabola, as what is mentioned. So the cable forms now a parabola. Okay, and then there are towers supporting the cable that is 400 feet apart, and each of them is 150 feet high. Now let's illustrate this word problem so that we can understand it more. So the cable at its lowest is 30 feet above the bridge at its midpoint. Okay, so we're talking about the lowest point of the bridge. So if we're talking about the lowest point, that means we're referring to the vertex of the parabola. So if the vertex is the lowest point, that means the parabola opens upward. And according to the problem, the lowest point is 30 feet above the bridge. So if we will draw it, it should look like this. So we have here this one is the cable. Then these are the two towers. So 1 and then 2. So each of them is 150 feet high, so as you can see. And then they are 400 feet apart each other. So from the center, the first one is 200 feet apart, and then the other one is also 200 feet away from the center. Now, for the vertex of this parabola, it's mentioned that its lowest, which is again the vertex, is 30 feet above the bridge. So this is now the vertex, and it's 30 feet above the bridge. So if this one is 0, so 30, that means the coordinates that represents the vertex is 0, 30. Now, the question is, how high is the cable 50 feet away from either tower? So, if this is the tower, 250 feet away from it, that is 150. Okay, because we just subtracted 50 from 200. Okay, so how high? How high is this part, this point right here, which is part of our parabola, how high it is? So that is the one that we have to solve. So we know that the x-coordinate of that point is 150 since it's 50 feet away from the tower. And we're solving again for y because that represents the height of the cable. So please take note of the following. The vertex is 0, 30. And then we're solving for the y if x is 150. Also, we can consider this point right here, which is at the very top of our tower, which is x is 200 and then y is 150. Now, since we know that this is a parabola, so we will be using again the equation x minus h squared equals 4c times y minus k there. And then from the problem, we know that the vertex is 0, 30. So this point here. And then all we have to do is to substitute the vertex to our equation. So we have x minus 0 squared equals 4c times y minus 30. So this one is x squared equals 4c y minus 30. So this is now the equation that represents the cable, okay, or the equation of the parabola, which is the cable. So we have to identify the c first. So to identify c, of course, we have to get rid of x and y, or that means we need to assign values for x and y so that we will be left with c. Remember, we consider another point here, which is 200, 150. Okay, so let's use the values of x as 200 and y as 150, and then solve for c of this equation. So again, x is 200, and then y is 150. So we have x squared, so 200 squared, equals 4c times 150 minus 30. Simplify this. We have 40,000 equals 4c times 120. And then 40,000 equals 480c. And then divide both sides by 480. So c equals, now to get accurate results, let's use a fraction first. So let's simplify this. We will get 250 divided by 3. So we divide both numbers by 160. So now let's solve for the value of y given that x is equal to 150. So again, we have to identify how high. And the y-coordinate of this point represents the height of the cable. So that's what we are going to solve. Okay, so if x is 150, what will be the corresponding value of y? Okay, so let's use now the equation. And then substitute the values that we know. So x is 150 squared equals 4. Then c, we have 250 over 3 times y minus 30. Let's just simplify this. We have 150 squared is 22,500 equals, this one is 1,000 over 3 times y minus 30. To get rid of the denominator, let's multiply both sides by 3. This will be cancelled. And then you will have 67,500 equals 1,000 times y minus 30. And then divide both sides by 1,000. Since what we need is just the y, divide both sides, we will get 67.5 equals y minus 30. Then, last thing that we have to do is to move 30 on the other side. So that is 67.5 plus 30 equals y. Or we can say that y is equal to 97.5. Therefore, we can now say that the cable is 97.5 feet high if it is 50 feet away from the cable. If it is 50 feet away from the tower. So that is now our final answer. So if x is 150, the value of y is 97.5. For our last problem, a tunnel has the shape of a semi-ellipse that is 15 feet at the center and 36 feet across at the base. At most, how high should a passing truck be if it is 12 feet wide for it to be able to fit through the tunnel? Round off your answer to 2 decimal places. So looking at this word problem, we have this word semi-ellipse. So that means we are going to use the concepts that we know about ellipse to solve this problem. Okay? So again, we have here a tunnel. So this time it is, the shape of this now is semi-ellipse. So again, to visualize, of course, it is better if you will illustrate it and then you will put it in a Cartesian plane so that we can identify certain points that we can use in order to solve. So let's say we have here this one. This is the Cartesian plane, and then this red curve here, this one right here, this is the semi-ellipse tunnel. And from the problem, we know that it is 15 feet high at the center. So this is the center. So as you can see, we use again the origin as the center. So again, it's better if you will maximize our origin so that we can solve it easier. So we have here, so this one is 15 feet high. And another thing that we know is that the base is 36 feet across. So if we will divide it into 2, so we have 18 and the 18 on the other side. At most, how high should a passing truck be if it is 12 feet wide? So it should be 12 feet wide. So let's say this one, this rectangle right here, this represents the truck, and then its width is 12 feet. So if we will put it at the center, so we'll divide it into 2. So this one is 6, the other one is also 6. So how high should the passing truck be? So let's say, of course, truck can be shaped like a rectangle. So this one, this line segment right here represents the top of our truck, and its edges touches the tunnel, this two right here. So we have to identify the points here because these points represent now the highest point of the truck so that it will fit now to our tunnel. This point right here is part of the ellipse, and we know that half of this is 6. Therefore, the x-coordinate of this point is 6. Now, we have to identify what is the y-coordinate. So, the y-coordinate now represents the height of the truck. So, that's the one that we have to identify now. So, in solving that problem, so we will be using the ellipse. And as you can see, this one is a horizontal ellipse, half of a horizontal ellipse. So, that means we will be using the formula x minus h squared over a squared plus y minus k squared over b squared equals 1. From the problem, we know that the center is 0, 0. And we can also identify the values of a and b. Remember, a represents half of our major axis. B represents half of the minor axis. Since this is horizontal ellipse, our major axis is also horizontal. So this is our horizontal axis. And half of this, which is this one, is 18. So we can say that A is equal to 18 because the whole base is 36. For B we know that is for the minor axis. So the minor axis now is vertical. So this segment right here is our minor axis or half of our minor axis. And this one is a 15. So B is 15. Using these values that we know, let's use this and then substitute to our formula so that we can get the equation that represents the ellipse. So we have x minus 0 squared over a squared, so 18 squared, plus y minus k, y minus 0 squared over 15 squared equals 1. Then simplify this, we have x squared over, then 18 squared is 324, plus, then we have y squared over 15 squared is 225 equals 1. So this is now the equation of the ellipse that represents the tunnel. If we will continue, this is a whole ellipse. Now after that, we have now to identify what will be the value of y given that x is 6. Again, this point right here is part of the ellipse. So we can use this equation to identify the value of y. So x is 6. We have to know what is the value of y. So now let's substitute. So we have here 6 squared over 324 plus y squared. We don't know that. 225 equals 1. 6 squared is 36 over 324 plus we have y squared over 225 equals 1. Let's simplify. Let's write here again. 36, 324 plus y squared over 225 equals 1. Now let's simplify 36 over 324. So that will give us 1 over 9. And then plus y squared over 225 equals 1. Okay, so now let's manipulate this in order for us to solve for y. So we can move 1 over 9 on the other side. So we'll just have y squared over 225 equals 1 minus 1 over 9. So if you simplify this, we will get 8 over 9. Then after that, let's multiply both sides by 225. Why do we have to multiply both sides by 225? So that we can cancel this and then we will be left with y squared only. So we have y squared equals 225 times 8 over 9. That will give us 200. And then get the square root of both sides. So we have y equals square root of 200, or the estimated value of that will be 14.14. Therefore, we can say the track must be at most 14.14 feet high, 2 feet through the tunnel. So there you go. So given that the truck is 12 feet wide, so it must be at most 14.14 feet so that it will fit into the tunnel. And so this one, the value of y here must be 14.14 feet. So that's it for today. I hope you learned something about solving word problems involving conic sections, and see you next time.